All right, so here we are with our second review lesson from this evening, and this is going to, for students in, for the O3 and O2 level students, this really doesn't have as much relevance other than there's a little bit of fraction practice and stuff. Really, this is an O52, O53 topic. It's skills with working with fractions, working with variables, working with order of operations that are going to come up throughout your course. So, first of all, we're going to talk about something called a complex fraction. A complex fraction has the numerator and the denominator will either both or one of them contain a fraction. So we have some examples here, and you see we have fractions, but inside the fractions, we have more fractions. That's called a complex fraction. And our strategy for these is to remind ourselves that that fraction bar is really just another way to write division. So 2/3 over 5/6 is really just 2/3 divided by 5/6. That's what it actually means. 4 over 6/11 is actually 4 divided by 6/11, and a half over 10 is really just a half divided by 10. And so we convert these into a division, and then we use our rule for dividing fractions. That's where we change division of a fraction to multiplication by the reciprocal, and that allows us to work these out. So let's try these one at a time. 2/3 over 5/6 is 2/3 divided by 5/6. And now remember our rule for division. We change the division sign to a times, and we flip the second fraction, like so. And now we can proceed, multiply the tops and multiply the bottoms. 2 times 6 is 12, 3 times 5 is 15. I also see some canceling I can do here. I think I didn't do the canceling method this time. Yeah, so 2 times 6 is 12, 3 times 5 is 15. And you notice that because I didn't do the canceling up here in the multiplication, I do actually have canceling now. Both the top and the bottom can be divided by 3. So we end up with 4/5 for this answer. And I think I make a little note here. Yeah, if we had been on the ball, we would have canceled before multiplying. Right at this step here, I would have noticed, oh, hey, 6 and 3 are both divisible by 3. Cross them out and divide. 6 divided by 3 is 2. 3 divided by 3 is 1. And look, we would have got right to our answer if we had gone that way. 2 times 2 is 4. 1 times 5 is 5, 4/5. Okay, so either way, I would say when it's one like this, I'm inclined just to multiply the tops and bottoms, then reduce because the numbers are small. When the numbers get bigger, it's definitely worth reducing first. And we looked at that a lot on Monday, I know, in our last class. All right, so 4 over 6/11, 4 on the top, 6/11 on the top, actually means 4 divided by 6/11. Let's follow our rule, change the division to a times sign in red. Oh, sorry, I lied before we get there. We can't do anything with fraction work until everything is a fraction. So that 4 has to become 4 over 1 before we can do anything, right? So the whole number 4 becomes 4 over 1. Now we apply our division rule, change it to multiplication, and flip the second fraction. Let's look for reducing this time, I think. I see the 4 on the top and the 6 on the bottom that can both be divided by 2. So I cross them out. 4 divided by 2 is 2. 6 divided by 2 is 3. So there's my reducing. And now I multiply the tops. 2 times 11 is 22. And 1 times 3 on the bottom is 3. So we reduce that fraction first, and it saves us having to reduce it at the end. But again, this one wouldn't have been too bad if you multiplied first and then reduced. And then read the instructions carefully. Do they ask for an improper fraction or a mixed number? 3 goes into 22 7 times with 1 left over, so 7 1/3. So there's that example. Let's look at the third one. A half on the top and 10 on the bottom actually means a half divided by 10. We can't do any fraction work with the whole number 10. So we turn it into 10 over 1 because everything has to be a fraction to do fraction work. Now we say, oh, and let's remind ourselves not to be tempted to cancel here, right? You see the 10 and the 2, but no, it's division. So that canceling only happens for multiplication. So I turn that into multiplication, half times 1 over 10, and in fact, nothing does cancel, we see in this case. 1 times 1 on the top, 2 times 10 on the bottom. So there's a few examples, simplifying complex fractions. I think that's all for that. Yeah. So watch for those. And now we're going to bring in also order of operations. So here we're going to have some exponents or some adding, subtracting, multiplying, dividing, possibly some brackets. And we need to follow our order of operations rules. And these can get pretty messy looking. So I would strongly recommend following this strategy. Work out the numerator and the denominator each separately. Just go off to the side, work each of them out, then put it all back together to get your final answer. So we're going to do these one at a time. Here's the first one. And I am going to go off to the side. I'm going to work out the numerator, work out the denominator, and then figure out my answer. So for the numerator, 1/3 squared, well, that means 1/3 times 1/3, which is 1/9. So that's what's going to happen on the top. For the denominator, 14 minus 2 cubed. 14 minus, so we do the exponent first there. 2 cubed is 8. And now subtract 14 minus 8 is 6. And remember, why is 2 cubed 8? Because 2 cubed means 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. Okay, so now I've got the top and the bottom worked out. Now I come back over here. I put a 9th in on the top and 6 in on the bottom. And this is actually now quite a bit like the questions we just did. 1/9 on the top and 6 on the bottom means division. 1/9 divided by 6. That 6 has to become 6 over 1, so we can do fraction work with it. Change the divide to times and flip the second fraction. 1/9 times 1/6. And multiply the tops and multiply the bottoms, 1 over 54. Okay, so work out the top, work out the bottom. Some people will you can work it out like all in, writing the whole fraction every time. It tends to get really messy and easy to lose stuff and make a mistake. So work out the top, work out the bottom, then put them back together and follow through the steps. Let's look at the next one. Was 6 plus 3 times 5 on the top and 9/5 on the bottom. So order of operations, do not go 6 plus 3, right? Multiplication first. 3 times 5 is 15. Now 6 plus 15 is 21. So the top works out to 21. The bottom, well, it's already worked out, 9/5. There's nothing to do there, right? You can't simplify that anymore at this moment. You could turn it into a mixed fraction, but you definitely don't want to do that because you need it as an improper fraction to do the math work. So let's go and put those back in. The top is 21, the bottom is 9/5, which we know means 21 divided by 9/5. We can't do anything with that 21 unless we turn it into a fraction. We can't do any fraction work with it, I should say. The division turns into a times and the second fraction flips. That's our division rule. And those numbers are going to get big. Let's see if we can do some canceling first. 21 can be divided by 3, and so can 9. So I cross them out. 21 divided by 3 is 7. 9 divided by 3 is 3. There, that will help the simplification greatly. Multiply the tops. 7 times 5 is 35. Multiply the bottoms. 1 times 3 is 3. And there you go. So we worked out the top and bottom. We put them back in. We did our division. Came up with an answer. Read the question carefully. The instructions, do they want 35 over 3 or 11 2/3? So, and then we had one more example. Yeah, I guarantee you'll see one of these on your Chapter 2 test. So we have fraction addition in the top, a fraction subtraction in the bottom. Let's work them both out separately. Otherwise, it's just a huge mess. So on the top, we have 1/8 plus 5/8. Well, that was nice. We made those already have a common denominator. So 1/8 plus 5/8 is 6/8. Always reduce if you possibly can. So 6 and 8, top and bottom divide by 2, and we get 3/4. Over here, I wasn't so kind. We have a 3 and a 2 as our denominators. What is the lowest common multiple of 3 and 2? The smallest number that 3 and 2 both go into? It is 6. So I rewrite that step, but with 6's in my denominators. What did I do to the 3 to get 6? I multiplied by 2. So I also multiply the top by 2, getting 4. What did I do to the 2? I multiplied 2 times 3 to get 6. So I also multiply the top by 3. There we go, 4/6 minus 3/6. And now I can do my subtraction. I get 1/6. And there we go. I've got the tops. The top worked out to 3/4, the bottom worked out to 1/6 using my fraction addition and subtraction. So I take those and I put them back in the fraction now that I've worked them out. The fraction bar is another way to write division. So this is 3/4 divided by 1/6. Turn the division to multiplication and flip the second fraction, which is how we do division for fractions. And let's try to cancel. I see a 6 on the top and a 4 on the bottom. Swipe them out and divide both by 2. So 6 divided by 2 is 3, 4 divided by 2 is 2. I don't see any more canceling of tops and bottoms, so that's as far as I can reduce. Now we do the multiplication. 3 times 3 on the top, 2 times 1 on the bottom. And do they want that as 9/2, or do they want you to turn it into 4.5? Read the instructions to find out. All right, so when you see those really big, messy looking fractions with stuff to work out on the top and the bottom, my highest recommendation is work out the top, work out the bottom, then put them back together and find an answer. There's one I say we're going to take. I think we're going to keep pushing through because we want to make sure we have time for questions as well. So reminder here, the 2 is going to need to become a 2/1. So let's work through this one. In the numerator, I have 2 minus 1/3. In the denominator, I have a 6 plus 3/10. The 2 needs to become a 2/1, otherwise I can't do any fraction work. I am subtracting fractions, which means I need, I need the denominators to be the same, right? 1 is a 1, 1 is a 3. Now you remember this is something we looked for. Instead of doing the whole lowest common multiple and listing everything off, watch for that special case where one of the denominators goes evenly into the other, because I can just go 1 times 3 and then my denominators match. So I'm going to do that. Multiply that fraction top and bottom by 3. So I get 6/3 minus 1/3. 6 minus 1 is 5. And so 5/3 is the top worked out. Let's come over here now. This one's not as nice. I have 6 and 10 as my denominators. I need the smallest thing that 6 and 10 go into. We know that everything 10 goes into ends in a 0, so our simplest method here is to list off the multiples of 6 till we get to one that ends in a 0. And there we go. 6, 12, 18, 24, 30. Yeah.
So should we reduce the 6 and the 3
Right here?
in the denominator?
So if you did, you would get back to 2/1.
No, on where it says 1/6 plus 3/10. Like 3 in 1 and 6 goes.
Right. A great
I don't
question.
know.
Can
Do
you
we do
reduce the
that?
6 and the 3 there? When is the only time you can cancel the tops and the bottoms? It's when
Maybe when you have a common denominator?
No, it's when it's multiplication.
Okay.
The only time, so we did this, I don't have any here, there'll be some, I'm sure. So this is what we stressed over and over and over when we did that. Only for multiplication, not for division, not for addition, not for subtraction. You cannot do the canceling thing between the fractions unless it's multiplication. So yeah, no, it's a plus sign, so no, we cannot reduce there. Okay. We look for that common denominator so that we can add the fractions. What did I multiply 6 by to get 30? I multiplied by 5, so I do the same to the top. What did I multiply the 10 by to get 30? 10 times 3 is 30. So I get 9 on the top. So 5 30ths plus 9 30ths gives me 14 30ths. Oh, look at that. That does reduce, right? That single fraction, divide top and bottom by 2 to get 7/15. Okay, let's come back over here. We've now worked out the top and the bottom, 5/3 and 7/15. This is division, and we're going to, here, Lathina, we're going to say the same thing here. You might be tempted to see the 5 and the 15 and want to reduce it, but look at it's a division sign. Only multiplication. So here, when we had a 6 and a 3, right? You cannot cancel those between the fractions because it's addition. Here, between the fractions, we have a 5 and a 15. You cannot cancel because it's division. But, yeah, I even got that in there. Can't cancel the tops and bottoms until we have multiplication. So dividing is multiplying by the reciprocal. Multiplication. Now I can look for canceling. So is there anything that comes out of top and bottom? Yes. 3 and 15, right? Both divide by 3. So now that it's multiplication, I can cancel. 15 divided by 3 is 5. 3 divided by 3 is 1. I end up with 25 on the top and 7 on the bottom. 1 times 7. Which as a mixed number is 3 and 4/7. Okay, so hopefully that helps. And yes, I'm glad that question came because so common, right? People learn all their fraction operations and then they see the canceling on multiplication, which is really critical because it avoids you getting big numbers, but you cannot do that for addition, subtraction, or division. That is only something that works for multiplication. And the reason it works is because remember when you multiply, you just multiply the tops and multiply the bottoms, right? So anything that is multiplied into both the top and the bottom can come out, can be canceled out, but not for any other operation. Okay, last thing we're going to talk about here is we are going to bring in some letters, but it's really no different. We're just plugging in numbers for the letters. So b plus 2c, we've been asked to evaluate b plus 2c when b is 3/4 and c is 2/5. So whenever you are asked to plug in numbers for letters, my recommendation is to put a bracket there. So you can see I've replaced the b with a bracket, plus 2, and I replace the c with a bracket. I have rewritten this exactly the same, but with a bracket for each of the variables. And then fill the numbers in that go in those brackets. So b is 3/4, goes in the b bracket. C is 2/5, goes in the C bracket. And once you've done that, we just have an expression to work out. It's all numbers now, right? We replaced the B and the C. So let's work this out step by step. I got to do some bed mass here. 3/4 plus, what happened there? Why do I have 2 steps showing the same? I'm not sure. I'll fix that later. So remember the 2 has to become a 2/1, right? Because I can't do fraction work with it as a 2. Now I have multiplication here. I'm going to do this multiplication before I do the addition. Oh, I see what I did. I just meant to have an extra slide. So the 3/4 there. And then what we want to look at is we want to look at those brackets. So if you're thinking order of operations, you know you do brackets first, but remember that actually just means if there's anything to work out inside the bracket. This bracket over here just has a 2/5 in it, nothing to work out. This bracket has a 3/4, nothing to work out. This bracket is holding the place, it's showing multiplication, right? It's showing that these two things are multiplied. So I have to keep that there until I do my multiplication. This bracket here isn't doing anything. It's not showing, there's nothing being multiplied, right? It's not representing anything, so I can just drop that one. Now I'm going to do the multiplication first because of order of operations. 2 times 2 is 4, 1 times 5 is 5. And now I'm into the addition. Oh, this is a big question. I got to get a common denominator. The smallest thing that both 4 and 5 go into is 20. I multiplied 4 by 5 to get 20, so I do the same to the top. 3 times 5 is 15. I multiplied 5 times 4 to get 20 there, so I do the same to the top. I multiply by 4 to get 16. And now that I have a common denominator, I can add the fractions, 31 over 20, or if they want a mixed number, 1 and 11/20. All right, so you can see these are starting to get a little bit more involved, these questions. Let's try another one. 3m squared n, where m is a sixth and n is 3/5. So I am going to replace the m with a bracket and the n with a bracket. And in those brackets, I put the numbers. M is a sixth, n is 3/5. And then I'm going to work out the order of operations here. I'm going to notice that 3, I'm not going to be able to do any fraction work with it as a 3, so I changed it into 3 over 1. Now let's go through order of operations. BEDMAS, brackets. Is there anything inside a bracket to be worked out? No, there's not. This bracket is already worked out to a sixth. There's nothing more we can do with that. This is worked out to a 3/5. There's nothing more we can do with that. After brackets is exponents. Are there exponents? Yes, there are. 1/6 squared. So that is 1 squared, 1 times 1, over 6 squared, 6 times 6, 1 over 36. And now, what's next? Well, all we have left is multiplication. 3 over 1 times 1 over 36 times 3 over 5. Everything is multiplied. Because we have all multiplication, we can cancel any of the tops with any of the bottoms. And again, let's stress only because it is multiplication. We could not do this if there was any addition, division, or subtraction in there. Right, so let's look for any of the tops that cancel with the bottoms. I see 3 and 36 can both be divided by 3. Swipe them out, divide them both by 3. 3 divided by 3 is 1. 36 divided by 3 is 12. Anything else? 5, no, 3 and 12. Yes, I can keep going because the 3 and the 12 are both divisible by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So I made this significantly simpler. I was going to have to do 36 times 5 on the bottom. Now I only have to do 4 times 5. So the top is 1 times 1 times 1. The bottom is 1 times 4 times 5, 20. So 1/20 is the answer. I think I put a box around that. No, I don't. Yeah, so again, I think the key to notice here is that once we're down to all multiplication and nothing else, we can do canceling with any of the tops and any of the bottoms. I think I got one more here for you to try. Well, let's just, I think, keep pushing through, actually. So -7/10 plus s times t. So let's take that first step where we plug in the s gets replaced by a bracket and the t gets replaced by a bracket. Those numbers go inside the brackets, -1/4 and -3/5. Now, order of operations, so this is -7/10 plus, so that's going to be the last thing we do. This times that multiplication is going to be the first thing we do. So a few things happened here. Negative times negative becomes positive. On the top, 1 times 3 is 3. On the bottom, 4 times 5 is 20. Like, you make sure that makes sense to you. So now we have negative 7/10 plus 3/20. Got to be really careful here on the negatives and positives. We need a common denominator, right? We have tenths and 20ths, and we're adding fractions. So we need them both to have the same denominator. We notice we have the lucky case here where 10 times 2 is 20. So I'm going to do that. I'm going to multiply top and bottom by 2, creating 20s on the bottom. So now we have negative 14/20 plus 3/20. The bottoms are both 20. So our answer is going to have a denominator of 20. See all there in green, right? When you add or subtract, once you have a common denominator, the bottom stays the same. What about the top? Because these negatives can get confusing. We have, remember how we want to think about this. This says go to the left on your number line, 14, and go to the right on the number line, 3. And I could ignore the 20s because I know the bottom's going to be 20. All I care about is I'm going left 14 and right 3. Or we could even say 14/20 left on the number line and 3/20 right on the number line. But again, all we need to think about is the 14 and the 3. So 14 left and 3 right, negative 14 plus 3 is negative 11. And that is what pops in for our final answer there. And I got one more slide. Why do I have... Oh, yeah. Okay. So negative 11/20. I just make a little note here at the end. We could have also said negative 11 over 20. That is actually the same as... I've just erased this by accident. Negative 11/20 is the same as negative 11/20. Those are just two ways of saying the same thing. Probably that's the one that is making more sense to us, though. Negative 14 plus 3 is negative 11.